Hi everyone, my name is Bingbing. So now I'm going to show you how we solve question number 2 on homework 3. So on this question, it says x is a uniform in the range a and b, and y is equal to x squared. So on part A, it says find and draw fxs and big fx. So in order to solve part A, we know that since y is equal to x squared, so when x is greater than or equal to a and smaller than or equal to b, you plug in x and you get fxs is equal to 1 over b minus a. And if x is smaller than a or x is greater than b, so it's not in the above range, then you get fxx is equal to 0. And when x is smaller than a, on the fxs is equal to 0. And when x is greater than or equal to a and smaller than or equal to b, you get fxx is equal to 1 over b minus a times x plus 1. And if x is greater than b, then you get fxx is equal to 1. So you can draw the graph based on these values. So you get a is here is and a and b range, and this line should be when the x is greater than or equal to a or smaller than or equal to b, then you get fxs is 1 over b minus a. And also the same fxs is graph is look like this, and the highest point they can get is 1. So when x is greater than b, you get fxs is equal to 1. So, part B, it says given that a is equal to -1, -1, and b is equal to 3, and find and draw fyy and fyy and find ey. So on this part, when a is equal to -1 and b is equal to 3, so we can get fxx is equal to 1 over 4 when x is greater than or smaller or equal to -1, and x is smaller than or equal to 3. And we can also get when x is smaller than -1 or greater than 3, then fxx is equal to 0. And you also get this by plugging a and b from power A, and you get when x is smaller than a, fxx is equal to 0, and when x is greater than or equal to a, which means greater than or equal to -1 and smaller than or equal to 3, you get fxx is equal to x plus 1 over 4. And when x is greater than 3, you get fxx is equal to 1. So since y is equal to x squared, so you solve for y, you get you solve for x, you get x is greater than or equal to negative square root of y, and smaller than or equal to square root of y. So then you can get fyy is equal to 0 when y is smaller than 0 and y is greater than 9. So fyy equals to fxx1 over the absolute value of the derivative of gx1 plus fx2 over the absolute value of the derivative of gx2, which is equal to 1 over 4 square root of y. So when y is greater than or equal to 1 or smaller than 9, you get fyy equal to fxx over the square root of the derivative of gx, which is equal to 1 over 4 over the square root of 2 square root of y, and you get 1 over a square root of y. Then this is a range for the fyy, and also for fyy is when you plug in the number, so you get when y is smaller than 0, you get fyy is equal to 0, and when y is greater than or equal to 0 or smaller than 1, you get fyy is equal to 1/2 of square root of y. And when y is greater than or equal to 1 and smaller than 9, you get fyy is equal to 1 over 4 times square root of y plus 1. And if y is greater than or equal to 9, you get fyy is equal to 1. Since so based on this range, we can now get the uniform equation for fyy is equal to 1 over 4 square root of y times uy minus uy minus 1 plus 1 over a square root of y times uy1 y minus 1 minus u times y minus 9. And also for fyy is equal to 1/2 times square root of y, and uy minus uy minus 1 plus 1 over 4 times square root of y plus 1 times uy minus 1 minus uy minus 9. So now you find fyy and fyy. And we know ey is equal to 0 to infinity time the y minus fy dy, which is equal to 1/4 of the 0 to 1 and y times 1 over square root of y dy plus 1/8 of the 1 and to the 9 and 1 y times 1 over square root of y dy equals to, you plug in the 2 over 3 and here, and then you solve for the limit, and you get 7 over 3 is the answer for ey. So ey is equals to 7 over 3. And this is the graph for fyy, and this is the graph for fyy.